Hi guys, and welcome to another episode of Kabir Considers. In this video we're going to react to what happened when the USA nuked space. It's a declassified story. Now, I'm trying to think, why would the USA nuke space? To study the effects maybe of nuclear weapons, outside our planet, to kind of exercise, how a potential space war could go about. Like, to send a nuke into outer space, I just don't. It's an interesting topic though, because I imagine like the mushroom cloud and stuff like that, the way it forms is probably because of gravity on Earth. So if there's no gravity because you're in space, to be fair, I can actually see why. There's lots of good questions that would be answered by nuking outer space. But yeah, let's find out. All right, let's
Here
go.
is the thing about nuclear bombs. There is no good place to set one off. They are generally bad news in all scenarios. But there are a few instances where detonating a nuclear bomb is just a particularly terrible idea. One of those locations being outer space, which may come as a surprise. Space is far away and it's basically empty, right?
Yeah.
What's the worst that could happen? The United States military has a short but eventful history with nuking space. It's a strategy that was experimented with in the early days of the space race and the height of Cold War tensions with the Soviet Union from the late 1950s to early 60s. In theory, there were potential advantages to exploding a nuclear bomb high above the Earth, both from a defensive and offensive point of view.
I guess, yeah, from an offensive point of view, it shows that A, you're capable of doing it, and B, how powerful your weapons are, so that potential enemies, I guess, can see, don't mess with us.
As a defensive strategy, nuking space could work to shield the United States from a Soviet intercontinental ballistic missile attack. The idea being that when you explode a nuclear bomb, you create an electromagnetic pulse and a field of highly charged electrons. This is deadly to electronic devices, such as the guidance system inside a long-range nuclear missile.
I see.
You see, intercontinental ballistic missiles don't fly across the ocean like airplanes, they fly like rockets, blasting up through the atmosphere and crossing over into outer space before falling back down to acquire their final target. If they were to make their way back down through a shield of electromagnetic interference, it could damage or disable the missile's electronics. There's also an offensive strategy for nuking space. In the late 1950s, scientists confirmed that the Earth has a powerful magnetic field. It originates from the planet's core, where we have a solid ball of iron at the inner core, surrounded by a layer of free-flowing liquid metal in the outer core.
I wonder how big, that iron core is. Is it literally like some gigantic, just solid iron ball? I kind of want to see it.
The movement of that outer core acts like a gigantic electrical generator that powers the Earth's magnetic field, which extends out from the core and reaches far into space.
Wow.
This effect manifests itself as a series of circular magnetic field lines that flow from the southern hemisphere to the northern hemisphere. These form into concentric layers of magnetic field that encapsulate the Earth from the surface to hundreds of miles into deep space, like a gigantic magnetic space onion with a planet in the middle. The outer layers of this magnetic onion can trap highly charged radioactive particles from the sun and hold them out there in deep space, preventing them from reaching us down here on the surface. This is one of the key reasons that there is life on Earth.
Right.
So, thanks, magnets. And we can see this effect for ourselves when some of those charged particles are drawn down along the magnetic field lines and into the sky above the North Pole, aka the Northern Lights. Detonating a thermonuclear bomb is a lot like instantly creating a miniature sun, and if you were to do that inside the Earth's magnetic field, then you should get a similar result to what happens with the real sun. The highly charged radioactive particles will be trapped and drawn out along the magnetic field lines. But while the outer layers will direct their trapped particles over the North Pole, the lower-lying inner layers will dump their contained electromagnetic chaos into a lower latitude, such as the Soviet Union. Okay, that was a long explanation, but it's important to know all of that if we are going to understand why anyone would ever want to.
Yeah, that was a lot of science right there. I'm all scienced up.
Nuke space. It's not so much about the explosion itself, but the electromagnetic fallout it creates and how that interacts with the magnetism of the Earth. So theoretically, a thermonuclear explosion strategically positioned over the Indian Ocean would release an EMP that would be caught up in a magnetic loop and deposited on top of the Soviet missile defense system, rendering their electronics useless and neutralizing their ability to detect and defend against a long-range nuclear strike. Right. Of course, the only way to prove these theories was to set off a high-altitude nuclear bomb and see what happens. Remember, this was the late 1950s, and conducting live above-ground tests of immensely powerful nuclear weapons was the style at the time. Alright, I've got something for the military history buffs out there. This is War Thunder, the most comprehensive vehicle combat game ever made, and it's available now for free on both PC. Between the months of April and August 1958, the US military conducted a series of 35 nuclear weapons tests under Operation Hardtack. These took place in locations the government refers to as the Pacific Proving Grounds, which is a collection of tiny islands in the central Pacific Ocean that are so small most of the world wouldn't even know they exist. You have to zoom in.
So perfect places to test weapons and things like that. You just hope that there's absolutely nobody there.
10 times on Google Maps just to see them clearly. Of these experimental nuclear explosions, 3 of them would be high-altitude tests. The first, codenamed Yucca, would strap a 1.7 kiloton nuke to a hot air balloon and float it off into the upper atmosphere. Now, that sounds sketchy, and it was, but in fairness to the Army, they did spend 2 years practicing for this and deployed 76 test balloons before eventually letting one float away with a nuclear bomb. Yucca was deployed from a US aircraft carrier off the coast of Bikini Atoll on April 28th. The balloon was released at 11:25 a.m. It reached the target altitude of 85,000 feet by 12:50, and at 2:40 in the afternoon, the relatively small nuclear bomb was detonated. The importance of this test was to measure the strength of the electromagnetic pulse created by the explosion. Scientists had theorized that a high-altitude EMP would carry more intensity than a ground-based explosion, but they didn't know how much. Measurements from the Yucca confirmed that a high-altitude EMP can be more than 1,000 times more intense than the same explosion at low altitude. Now, as scary as that information might be, it was exactly the result that the military was looking for, so they pressed on.
What, did they test an even bigger nuclear bomb? Like, this can't be great for the environment. Even though it's super high up, the radiation and the fallout, that still goes places. And because it's so high up, isn't it going to like push it out further? Yeah, I mean, environmentally, this can't be very good, can it?
The next test, codenamed Teak, would replace the balloon with a Redstone missile and take the explosive yield up to 3.8 megatons. The location was moved to the government's most remote outpost, Johnston Atoll. It's west of Hawaii and about as close to the exact middle of nowhere as you can get. Teak was launched at 11:47 p.m. on July 31st. The warhead detonated at an altitude of 76 kilometers or 43 miles. That's not technically space, but it's pretty damn high. Unfortunately, the missile's guidance system wasn't programmed correctly, so instead of heading downrange over the ocean, Teak exploded directly above Johnston Island, creating a miniature sun within the Earth's atmosphere that was visible from 800 miles away at Hawaii and lingered in the sky for almost half an hour. The thermal radiation was strong enough to give the servicemen on Johnston sunburns. It
better get that checked. Get to the hospital immediately.
Also knocked out high-frequency communications across the Pacific for 8 hours after the detonation. Again, a pretty frightening effect from a relatively small bomb that really started to demonstrate the power of nuking space. So just for good measure, the US tried this one more time, codenamed Orange, on August 11th. This was another 3.8 megaton bomb on a Redstone missile. The difference was that Orange exploded at an altitude of 43 kilometers or...
So this was lower. This was much lower because the previous one detonated at 76 kilometers. Like a good, almost double.
27 miles. The result was considerably less spectacular than Teak. The explosion was only visible in the sky for about 5 minutes and did not cause the same communications breakdown.
Interesting.
So, now we know that higher altitudes do have a significant effect on the fallout from a nuclear explosion. What comes next?
Operation Fishbowl.
It would take a few more years of planning before the US Army was truly prepared to nuke space, but the time would finally come with Operation Fishbowl in 1962, same year as the Cuban Missile Crisis that almost ended human civilization as we know it. Probably just a coincidence, though. Anyway, this was about more than just a Cold War arms race pissing contest. Fishbowl was a joint effort between the military, the Atomic Energy Commission, and the Defense Atomic Support Agency. This was about continued investigation of the potential for high-altitude EMP, the interaction between radiation from the blast and the Earth's magnetic field lines, plus the effect of all this on radio communication. The Fishbowl tests were monitored by a large number of surface and aircraft-based stations in the wide area around the planned detonations and also in the southern hemisphere region of the Samoan Islands, which was known in these tests as the Southern Conjugate. The idea being that fallout from an explosion over Johnston Island in the northern hemisphere would get caught up in a magnetic field line connecting to Samoa in the southern hemisphere, which would create an aurora linking the two island regions. Looking through the actual results of Operation Fishbowl, they were pretty hit and miss on accomplishing their objectives. It's actually kind of shocking just how often they botched some of these nuclear tests. We're truly all lucky to be alive.
Yeah, I mean, obviously some sympathy should be given to them because, you know, this is the 50s. They had way, way inferior technology to what we have now. But still, if you're going to nuke space, you better be as sure as possible and, you know, dotted all the I's, crossed all the T's, all that stuff.
Anyway, the
Extra
first
careful.
planned test was codenamed Bluegill. This was June 2nd, 1962, and the warhead was launched from Johnston Island on a Thor rocket just after midnight. The missile was promptly lost on radar tracking, so they knew that they had just launched a nuclear weapon into space, but they didn't know where exactly it was. Luckily, the flight termination system was still connected and the missile was destroyed. That doesn't mean that the bomb went off. It was still in safe mode and the debris just fell into the ocean. Attempt number 2 was codenamed Starfish. This was a couple of weeks later on June 19th. Another Thor missile launched from Johnston. This one flew for 59 seconds before the rocket engine failed, and the missile broke apart at around 30,000 feet, raining down plutonium-contaminated debris onto the island and surrounding water.
Jeez,
Undeterred, the military pressed on with Starfish Prime on July 9th. This time, the Thor missile would carry its 1.4 megaton thermonuclear payload all the way to an altitude of 250 miles or 400 kilometers above the Earth's surface.
That is space for sure. I think like that's sort of where the International Space Station is in terms of altitude.
Where it would successfully nuke space. This would go down as the largest nuclear weapons test ever conducted in outer space. The thing about a nuclear explosion in space is that it does not look anything like what we generally picture a nuclear explosion to look like. There is no mushroom cloud because there's no dirt to get pulled up into the air. There's no fire because there's no oxygen to combust. But there is still an intensely bright light. It grows outwards from the detonation in a round spherical shape until it starts to gradually feather off at the edges into these short curly tendrils. It's like some type of sea creature or a cactus. It's kind of beautiful until you remember the terrible consequences of what you're looking at. The EMP generated by Starfish Prime was significantly more powerful than the scientists involved had been expecting. So much so that it overwhelmed most of their instruments and drove them off the scale, making it nearly impossible to get an accurate measurement. All we know is that it was higher than the maximum number the tool was able to measure. The EMP caused electrical damage on the Hawaiian Islands, 900 miles or 1,400 kilometers away from Johnston. It knocked out streetlights, triggered burglar alarms, and damaged telephone communications. After the Starfish Prime detonation, bright auroras were observed in the detonation area, as well as in the southern conjugate region at the Samoan Islands. A very large area of the Pacific was illuminated by the auroral phenomena from far south of the south magnetic conjugate area through the burst area to far north of the north conjugate area. This confirmed the theory that charged particles from the nuclear blast would be carried over great distances by the Earth's magnetic field lines. It was also said that resonant light from the explosion hung in the night sky over Johnston Island for several days. High-energy electrons from the explosion became trapped in the Earth's magnetic field, creating an inner radiation belt around the Earth. The intensity of electrons in low Earth orbit actually increased by several orders of magnitude.
I mean, this all doesn't sound good for the planet. I mean, maybe not the planet, maybe for us. Just kind of got to feel sorry for the people on the islands nearby, like particularly Hawaii. You know, you just hope that they haven't ingested any sort of radioactive fallout from these explosions.
As a result, 3 orbiting satellites were disabled within a matter of days. Remember, 1962, there weren't very many satellites up there at the time, and at least 6 more satellites failed over the following months as radiation damage ate away at their solar power and electric systems. In 1968, it was reported that electrons from Starfish Prime had lingered in the atmosphere for up to 5 years.
Gosh, 5 years?
The following year, 1963, the United States and Soviet Union signed an agreement that would ban all above-ground nuclear testing, although the French and Chinese would continue doing their own tests for decades to come, but that luckily put an end to the short history of nuking space. There were other tests done, but they weren't as big as Starfish Prime. What's really frightening is that Starfish wasn't even a particularly big test. There were plenty of bombs made that were 10, 20, or even 30 times more powerful. Many of them, unfortunately, still exist.
Yeah, like the Tsar Bomba, I think, is the most powerful. I think it's Russian.
Now, it kind of goes without saying that if anything similar were to be detonated today, we would have a pretty significant catastrophe on our hands. Many of the important satellites in orbit are radiation shielded, GPS satellites for example, but most of the 10,000 objects floating around up there are vulnerable. They wouldn't just fall out of space, but even worse, they'd all become a bunch of uncontrollable projectiles hurtling around up there until they eventually start smashing into each other and creating a field of orbital debris that grows exponentially and smashes more things until everything in orbit is smashed.
And then, obviously, how do you get through that? If we want to launch things, into space, how do you get through all that debris? Are there really 10,000 satellites in space? 10,000?
And then, of course, there's the EMP. You don't even need to blow your enemy up if you can just detonate a giant nuke in space directly above their country and send them back to the 1800s. Anyway, long story short, we know what happens when you nuke space. It's deeply fascinating and visually stunning, but equal parts terrifying and potentially apocalyptic. So let's hope we never see that again. Shout out to War Thunder again for sponsoring
Fingers
today's...
crossed. Man, I know that, the reasoning for those tests was just to see, how these weapons would react in outer space, how they could be potentially used both as a deterrent and as an offensive tool. But, God, you got to think, was there any sort of regard for the environment? When they made this decision to do it, did they sit and think, potentially, what if we're wrong about our estimates here? What if the destruction and the fallout is way larger, which it turned out to be, than we calculated? Because, the fallout and stuff, as we've seen in Chernobyl, it can last for a very long time. I think people in that region still have higher incidences of certain types of cancers than most other places on Earth. So, yeah, I think we've done enough of that now. Hopefully, we've done enough tests in outer space, and obviously, the deal that was signed by Russia and the USA has put an end to that. But yeah, human curiosity, it's a great thing. It's got us to where we are in terms of technology and medicine and things like that. But it can definitely have some unintended consequences. Thanks for watching, guys. If you enjoy my videos, help me out by liking and subscribing.